All right, so today we're going to talk about symmetry and what kind of that means, and two different specific types of symmetry. We're going to talk about reflection symmetry, and we'll talk about rotation symmetry. So you should find the resource page 3.1.5, which looks like this, right? You can kind of see all of that in there. And there's different types of shapes. We're going to talk a little bit more about all of these shapes and some characteristics with these shapes later on. So what I want you to do is I want you to, with your patty paper, I want you to try to answer these questions. So I want you to figure out, what do these shapes have a reflection symmetry? So again, if I cut the shape down a side and I was able to reflect it onto the other end, right? So if I cut this shape down here, I know that this whole piece right here would lie perfectly up here, right? So it has a reflection symmetry of that, right? I cannot have reflection symmetry this way, because notice that if I did this way and I moved this piece up, notice that this white triangle would not match up with the grayish triangle. But I could have reflection symmetry potentially over, this line. Or we want to see if it's over this line. It would not, because again, this would not match up perfectly over here. So again, we'd have to take that away. Right? So it looks like we only have really one type of symmetry. Everything needs to match up with the other side. So go ahead, I want you to figure out which of the pieces, and then draw all your possible lines of symmetry if you can. And then this again continues. What are the triangles that have reflection symmetry? What are your quadrilaterals that have reflection symmetry? And do you think there are things on this page that have more than 3 lines of symmetry? So go ahead and pause your video now and try to do that. Okay, so if we're coming back from pausing our video, I'm going to go ahead and I'm going to write the letter R next to things that have reflection symmetry. Okay, so starting with our first shape and kind of just going down, the regular hexagon is going to have a reflection symmetry, and here is one of my possible lines of reflection symmetry. So it'll lie perfectly over here. Okay, that's one of them. So again, this has a reflection symmetry, so I'll put R. So R equals reflection. Okay, the kite also has a reflection symmetry, so another R next to that. Rectangle, right? Horrible, that's a horrible line, but does have a line of reflection, so an R. Scalene triangle does not have a line of reflection. And notice that we have just a trapezoid. It's a regular trapezoid, unlike an isosceles trapezoid down here. So this one also does not have a line of reflection. Okay, equilateral triangle does, so R. Square does, so let's just say down here, R. Okay, and one that you might not have potentially known would be an isosceles right triangle, so that does right here. Because an isosceles triangle, like the rectangle, right, this piece is congruent to this piece is congruent to this piece, and isosceles, this piece would match up perfectly with this piece. That's the great thing about an isosceles. Let's see. Continuing on, so this needs an R next to it. A circle. Surprisingly, a circle also has reflection symmetry. This has multiple ways to draw your line through it. A rhombus also has reflection symmetry. Quadrilateral. So quadrilateral is just the name of a shape that has 4 sides. This unfortunately does not have any reflection symmetry. This one does, right? An isosceles triangle, right? Unlike an isosceles right triangle, this does not have 90 degrees, where your isosceles is this sides are equal to each other. Scalene. Scalene, again, the scalene triangle versus scalene right triangle, they both don't have it, so that's it. Isosceles trapezoid, yes. Let's put a little R next to it because this side matches up with this side for an isosceles trapezoid. A parallelogram. Right? A parallelogram does not have reflection, does not have a reflection um, symmetry. Okay. Because like if you think about trying to cut it this way, we can't really fold it. If I try cutting it this way, it's not really going to match up. That's okay though. We will discuss this type of symmetry if it does have any symmetry later on. Okay, a regular pentagon does have symmetry, right? So there's just one of the lines. Again, a pentagon just means, when it says regular, it means all the sides are equal. So that means that this regular hexagon, all the sides are equal. Okay, so going back to our questions, right? Which figures have a line of symmetry? Basically, we've answered that. What type of triangles have a reflection symmetry? We've kind of answered that. What type of quadrilaterals? Again, that's 4 figures, so that means 4. But this one, what shapes on your resource page actually have more than 3 lines of symmetry? So I do want to discuss that. Okay, so there's actually a couple of them that do have more than 3 lines of symmetry. Okay, a regular hexagon has more than 3 lines of symmetry. So again, here's 1, here's 2, here's 3, and think of if you can think of any more that will actually have a line of symmetry, because this one does have 6 lines of symmetry. Okay. Rectangle, we've already seen it with 1. Let's see if it has any more. So I know if I go down like this, that would be 2. I can't go across, so it looks like this one is only with our 2. Regular, sorry, not a regular, equilateral triangle. I can cut it this way. I can cut it this way. So this one has 3. So not that it has more than 3, so I'm not going to star it. Square, so this has at least 2, and then the wonderful thing about a square is that I can go this direction, right? So this one does have a little bit more, right? So it has 1, 2, 3, 4. So I'll put a little 4 next to that one. Okay, this one, and it's the only one. This one is actually very special. This has an infinite amount of lines of symmetry for reflection. So it just depends on how we want to cut it. I can cut it down the middle. I can cut it this way. Again, these are horrible cuts. They're not going exactly in the middle for that. Rhombus, it only has 2, so no more, no less, none here, only 1 right here, only 1 right here, and then a regular pentagon. So I'll start this guy as well. So again, I went straight down the middle. I can go from our side, so I can go from this end over here. There's 1, there's 2, there's 3, and then there's 4. So we got 1, 2, 3, 4, and then I can also go from here to here. So 1, 2, 3, 4. So this one actually will have 5 lines of symmetry. So again, not that you have to know how many lines of symmetry we have, but we want to have the basic ideas for the shape. Okay. So look at this shape, right? We learned about reflection symmetry. So examine, is this a polygon, right? Yes. Yes, it is. So big old yes. Polygon just means many sides, right? That's what a polygon is, right? Poly meaning many, gon is our sides. So can this thing can be rotated onto itself, right? So go ahead and try to the best of your ability kind of look at the shape, either recreate it or trace it, and then onto the pie paper, and then put the rotation in the middle, and then try to rotate it and see, like, will this kind of move up here? Alright, so go ahead and pause the video and see if you guys can answer questions B and C. Alright, so we're coming back from the video. Can this thing be rotated onto itself? So part, oops, not B, sorry, part B, right? The answer is yes, yes it can. Okay, so 360, right, we all the way around So if I break this up, and I divide 360 by 3, notice that I'm going to get 120. So that means every 120 degrees, it will rotate it on itself. So 120 degrees will get here. If I do another 120 degrees, I will get 240, and it will land, this piece would be over here. And then if I go all the way around 360, then it'll be perfectly fine. Okay? Just explains that she can rotate all polygons in such a way that they will not change. How does she do that? So what she's talking about right here is the 360. So any shape that you rotate will always have a reflection symmetry, like you rotated 360 degrees. So this will have a reflection symmetry if you want to rotate it 360. We don't want to call that reflection symmetry because it doesn't really change our problem, right? So that's what Jessica is talking about. So again, this is what we want to do. Since all polygons can be rotated 360 without change, that's not really special, okay? But if you can rotate less than, right, rotate less than 360 and still remain unchanged, it has rotation symmetry. So I want you to make sure that you do copy that down, okay? And that is why, right, we can go back to this slide and we can say that it has some reflection symmetry, or it could also have rotation symmetry, okay? So I want you to look at this page and I want you to see which one of these shapes would also have rotation symmetry. All right, so go ahead, pause the video for rotation symmetry now. All right, so if we're coming back for rotation symmetry, okay, let's talk about which ones would have rotation symmetry. So I'm going to say rotation symmetry. So RS is going to be rotation symmetry. Okay, the regular hexagon will have rotation symmetry. The kite will not. Okay, the rectangle will. Scaling triangle will not. The trapezoid will not. The equilateral triangle will. The square will. Okay, isosceles triangle will not. Circle, absolutely. Right, rhombus, yes. Quadrilateral, no. Isosceles triangle, no, no. This one, no. Parallelogram, yes, does have rotational symmetry. And last but not least, the regular pentagon also has rotational symmetry. So go ahead and make sure that you can see that it has rotational symmetry. You should have put your piece of paper kind of in the middle and then rotated it as long as, again, it's less than 360 degrees. And then coming back and answering this last question, E, kind of which shape have 90-degree rotational symmetry. So again, how we can double check is the addition sign, and then, because this will be a 90-degree angle. So if I move that dot, all right, doesn't matter if that dot is now here, right, or if I want to recreate it and that dot is right here, right? So so one would be 90 degrees clockwise, and this would be 90 degrees counterclockwise. So it doesn't really matter which ones. So there's only two, and the only two that we can see is the circle and the square. All right, so the circle and the square. Okay, so now let's see if we can talk about translation symmetry. So this is the question that part 2 will pick up on.